Hello everyone, welcome to our unit on slope. And to introduce you to slope, I want to give you an example from life that demonstrates slope. We can compare slope to skiing. Another word for slope would just be the word hill. A slope is like a hill. So in this picture here, where the skier is going up the hill, this would be a positive slope. In this picture here, where the skier is going down the hill, this would be an example of a negative slope. And in this picture here, where the skier is bored because it's flat and he's not going either up or down, it's just flat, this would be an example of zero slope. Now, suddenly it drops off and he falls. So this is going to be an example of undefined slope, or no slope at all. So let's get into our notes and talk about exactly what is slope. Slope is the measure of the steepness of a line. Okay, some other words for slope are rate of change. Okay, in a problem, if you see a rate of change, usually that's going to be signified by words like per, each, and every. Those kind of words are going to let you know that you're looking at a slope or a rate of change. Okay, in an equation like this, the slope is always the m. It's the number in front of x. On a graph, it's the rise over the run. And then it is also known as delta y over delta x, the change in y values divided by the change in x values. And we're going to be looking at several different types of situations and how do we find slope in each of the situations. Okay, first of all, let's talk about the types of slope. And again, just like in our picture, we said we have positive slope, which is like going uphill. We have negative slope, which is like going downhill. We have zero slope, which is flat. And then we have undefined slope, which is like a drop-off. Kind of like falling off the edge of the cliff. Okay, and I'm going to introduce you to Slope Guy here. He's going to help us remember our different kinds of slope. Slope Guy's left eyebrow is positive slope. His right eyebrow has a negative slope. His nose has an undefined slope, so we'll just put a U underneath his nose for undefined. And then his mouth has a zero slope, so we'll put zeros on either end for zero slope. So if you can remember this little picture right here, it will help you to remember the difference between the different kinds of slope. Okay, so how do we find slope when we're given two ordered pairs? Okay, so these are two ordered pairs. Remember, each ordered pair has an x and a y coordinate. Okay, I'm going to call this my x1 and my y1. This just means my first x coordinate and my first y coordinate. I'm going to call this my x2 and my y2, my second x coordinate and my second y coordinate. Using this formula, I can find the slope of the line that goes between these 2 points. So I'm going to plug into my formula. y2 is 2, y1 is negative 2, so 2 minus a negative 2. x2 is negative 1, and x1 is 4, so negative 1 minus 4. Now I just have to simplify. 2 minus a negative 2 is the same as saying 2 plus 2. So 2 plus 2, that would be 4. 1 minus 4, if we use our scoreboard, we have a negative 1 and a negative 4, so that would be a negative 5. And we can rewrite this as negative 4 over 5. We can kind of put the negative sign in the middle of the fraction. So our slope of the line between these 2 points is going to be negative 4 over 5. Okay, let's do some more examples using the slope formula. So again, here's our first x and our first y. Here's our second x and our second y. And now we're going to plug those points into our slope formula. So y2 minus y1, negative 2 minus negative 2. Negative 2 minus negative 2. Notice I have both the minus sign and the negative. Now x2 minus x1, so 7 minus a negative 2. So negative 2 minus a negative 2 is like saying negative 2 plus 2. Well, negative 2 plus 2 is 0. 7 minus a negative 2 is like saying 7 plus 2. So that would be 9. 0 divided by 9 is 0. So when we have a 0 on the top of the fraction, our slope is 0. Let's look at a second example. Here's my first x and my first y. Here's my second x and my second y. Why don't you pause the video right now and try this example on your own, and then press play to check your answer. Okay, let's see how you did. So y2 minus y1, negative 4 minus a negative 7. Again, notice how I have both the minus sign from the formula and the negative sign from the negative sign from the y coordinate. Okay, x2 minus x1 would be 6 minus 5. Negative 4 minus a negative 7 is the same as negative 4 plus 7. That would be positive 3. 6 minus 5 is 1. 3 over 1 can be simplified to 3. So the slope of the line between these 2 points is 3. Okay, let's do one last example. Again, go ahead and pause the video, try this example on your own, and then press play to check your answer. Here's our first x and our first y. Here's our second x and our second y. So y2 minus y1 would be 9 minus 3. x2 minus x1 would be 4 minus 4. 9 minus 3 is 6. 4 minus 4 is 0. Now notice how we have a 0 on the bottom of the fraction. Imagine that you had $6 and you wanted to split those $6 between 0 people. Can that be done? Well, no, that doesn't really make sense. You can't split $6 between 0 people, because you are one person, so you're giving the money to at least one person. So dividing something by 0 does not make sense. Okay, whenever we have 0 on the bottom of the fraction, that means that we have something that is undefined. Okay, so this is an example of an undefined slope or no slope. Okay, that if we were to graph it on a graph, it would look like this. It would be a vertical line. It's our drop-off situation. Okay, all right, so let's look back at the zero slope and the undefined slope. Notice where the zero is when we have the zero slope. The zero is on top of the fraction. Okay, so to help you remember that, I'm going to say that a zero on top of the fraction is okay. It's okay to have a zero on top of the fraction. However, it's not okay to have a zero on the bottom of the fraction. We'll say that is NO, because that results in an undefined slope. So again, 0 on top of the fraction is okay. 0 on the bottom of the fraction is no way, undefined. All right, so let's go to finding the slope from a table. Okay. Slope is just basically the difference or the change in y values divided by the change in x values. We have that as one of our definitions. Slope is delta y over delta x. This triangle means delta, and it means change in. So this is read as change in y. This is read as change in x. So we're going to look at this table and find our change in y and then divide it by our change in x. So let's just start by finding the change in y every time. We have 5 minus 1, so y is changing by 4. It's increasing by 4. Now we've got 11 minus 5, so y is increasing by 6. And now when we go from 11 to 13, y is increasing by 2. Let's see what the x values are doing. Well, x is increasing by 2, then it's increasing by 3, then it's increasing by 1. Now to find the slope, we have to do the change in y divided by the change in x. So let's do that for the first ordered pair. Our change in y over change in x is going to be 4 over 2. And that simplifies to 2. Let's check our change in y over change in x here. It's going to be 6 over 3. So 6 over 3. Notice that 6 over 3 also simplifies to 2. 2 over 1. 2 over 1 also simplifies to 2. So our change in y over change in x for each ordered pair in this table is 2. So our slope in this table is 2. Okay, go ahead and find your change in y and your change in x in the second table. And then press play to check your answers. So for the y values, first we are decreasing by 3. Then we're decreasing by 3 again. And then we're decreasing by 3 again. So each time the y value decreases by 3. Let's see what's happening to our x values. So x is increasing by 2 here. It's going to increase by 2 from here to here. 0 to 2 is plus 2. And then from 2 to 4, it's also increasing by 2. So we can see that our change in y over change in x is going to be the same every single time. So we only have to calculate it for 1 here because it's the same every time. It's going to be negative 3 over 2. And we're going to leave our answer in fraction form, because when we get into our graphing unit next time, it's going to be very helpful to be able to graph these. Okay, so summarizing, finding slope from a table is simply finding the change in y and then dividing it by the change in x. In our first problem, each time the change in y divided by the change in x gave us 2. In our second problem, each time the change in y divided by the change in x gave us -3 over 2. Okay, let's go on to finding slope from an equation. When you have an equation in this form, y equals mx plus b, the number in front of x, the m, is the slope. So the number in front of x is always the slope. So let's look at this example here. We have y equals -1/2 x minus 5. Let's circle the number in front of the x. Well, it's -1/2. So our slope is -1/2. Circle the number in front of the slope in the next equation. You should have circled the 3. So since the 3 is in front of the x, our slope must be 3. Okay, look carefully at this third equation here. What difference do you see between this equation and these two equations? If you said that the y was by itself in these two equations and it's not by itself over here, you are correct. Before we can find the slope in the equation, y has to be by itself. Okay, so solve for y first, because y must be alone before you can find the slope. So this looks like the literal equations that we were solving a couple of units ago. So to get y alone, the first thing we need to do is we need to get the -2y alone by subtracting 3x on both sides. Remember that we are not going to subtract the 10 and the 3x because they are not like terms. So we are going to write them next to each other. Okay, now that we have the -2y alone, we can work on getting the y alone by dividing everything by -2. When we do that, we get y equals 10 divided by -2 is -5. -3 divided by -2 would give us a +3 over 2x. So let's look for the number in front of the x, because that's going to be our slope. So the number in front of the x is the 3 over 2. So that is our slope. Okay. We have one more situation to look at for finding slope, and that's finding slope from a graph. Slope on a graph is always the rise over the run. So what we're going to be doing is choosing 2 points on a line and then counting how much we have to rise and how much we have to run to get to the next point. So I'm going to choose this point right here and this point right here. Notice that I chose what I'm going to call a pretty point. This is a pretty point because it is right at the intersection of 2 lines on the graph. Okay, now I need to count my rise. The rise is how much I move up or down. And I'm always going to move from left to right. So to move from this point to this point, I need to go up and I need to go to the right. So I have to go up 1, 2, 3 units, and up is going to be in the positive direction. So I'm going up 3, and then I'm going to the right 1, 2, 3, 4. And when I'm moving to the right, I'm moving in the positive direction of x. So this would be a positive 4. So my rise over my run for this line is going to be 3 over 4. So my slope of this line here is 3 over 4. Okay, let's find the slope for this line here. So we're going to start at this point because it's the furthest to the left. And now I'm going to pick another pretty point on the line. I could pick this point, but I noticed that this point is a little bit closer, and it's also a pretty point because it's right at the intersection of these two lines on the graph. So now I'm going to count my rise over my run. The rise is either up or down. So this time I'm going down 2. So down is in the negative y direction. So I have a rise of negative 2. And then I have a run. This is in the positive x direction. We're going to the right. A run of 1, 2, 3, 4, 5, 6. So my rise over my run on this line is negative 2 over 6. And I can simplify that by reducing this fraction to negative 1 over 3. So my slope, or my rise over my run for this line, is negative 1 over 3. Okay, I'm going to have you guys do the next one on your own. Let's start with this line right here. Please count the rise over the run and write your slope, then press play to check your answer. Okay, so on this line, we're going to move from left to right. So our rise is going down, and we have to go down 1, 2, 3, 4, 5. So our rise is negative 5, and our run looks like positive 2. So our rise over our run for this one right here is negative 5 over 2. Okay, press pause and then calculate your rise over your run for this line right here. You do not have to use these 2 points. You can pick other points that are pretty points that come right at the intersection of 2 of the graph lines. Okay, I'm going to choose this point, and I'm going to choose this point right here. Those look like pretty points. So I'm going to move from left to right. I'm going to have to rise 1. So this is going to be a plus 1. And then I need to run 1, 2, 3, 4, 5, 6. So I'm going to run 6. And this is to the right, so that's going to be a positive 6. So my rise over my run, or my slope for this line, is going to be 1 over 6. Okay, so now we need to look at the horizontal line and the vertical line. So let's look at our different kinds of slope. A horizontal line always has a 0 slope, and a vertical line always has an undefined slope. Okay, so this is going to be a 0 slope. Okay, and let's see as we count the rise over the run if this does work out to be a 0 slope. So to go from this point to this point, how much do we have to rise? Well, we don't have to rise at all. So our rise is 0. How much do we have to run? We have to run 1, 2, 3, 4, 5 to the right. So that would be 0 over 5. And remember we said that 0 on the top of the fraction is okay. That gives us a 0 slope. Okay, so when we count the rise over the run, we find that a horizontal line does indeed have a 0 slope. Okay, this vertical line here we know is going to have an undefined slope, and you can abbreviate that if you want to. Let's count this and make sure that it really is an undefined slope. Okay, so what is the rise between these 2 points? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have to rise 11, and how much do we have to run between these points? Well, we don't have to go either left or right, so our run is 0. And remember before we said that 0 on the bottom is no way, it's undefined. So by counting, we do find that this line, this vertical line, has an undefined slope. Okay, turn to the back of this notes page, and there's one thing that we want to go over. All of these tables and graphs and equations that we looked at on the page before are examples of linear functions. A linear function is going to be a function that always has the same slope or the same rate of change. And the graph of a linear function is always going to be a line. Okay? Linear functions are like a family of functions. Okay? They're all related to each other. And just like a family always has a parent, well, the linear functions also have a parent function. The linear parent function is y equals x. This is the simplest linear function that we can write. Okay, and we call it the linear parent function. Okay, and the unique thing about the linear parent function is that the exponent on the x is always 1. We haven't written that exponent in there, but we could write the exponent there. Remember, if there is no exponent written on the variable, it's understood to be a 1. So here's some examples of linear functions. This is a linear function because the exponent on the x is a 1. Y equals negative 5x plus 7 is also a linear function because the exponent on the x is a 1. Okay. In this equation, I want you to circle the exponent on the x. Notice that it's a 2. So this means that this is not a linear function because the exponent on the x is a 2. Circle the exponent in this equation. You should have circled a 3. This is also not linear because the exponent on the x is a 3. So to sum up, a linear function always has the same slope or rate of change. Its graph is always a line. The linear parent function is y equals x. This is the simplest linear function that we can write. The exponent on the x in a linear function is always 1. If it is any other exponent, like 2 or 3 or anything else, then it is not a linear function. Okay, that's all for today.